Good evening, everyone. I hope everyone is good. Had a good week. We'll just let the last few come in from the waiting room, and then we'll kick off. Oh dear, weather's getting colder. It was cold out there today. Been putting up the external Christmas lights. Yes, it's getting festive here in Bedfordshire.
Daz didn't pay attention to the talk last week about light pollution, obviously.
No, he did. Obviously, they're all downward pointing Christmas lights. That's the... damn, that's embarrassing, isn't it? There we go. There we go. Right, I think... moving swiftly on. Thanks, Grant. Yeah, good one. Right. Let's just move on then. So this evening we have great pleasure in welcoming Ezzy Pearson to give us a talk on the Chelyabinsk Meteor. So Ezzy is a science writer and author of Robots in Space, The Secret Lives of Our Planetary Explorers. She is, of course, also the news editor of the Sky at Night magazine, which I'm sure we all subscribe to. Back in February of 2013, there was a meteor that detonated over the industrial town of Chelyabinsk in Siberia. And as you would expect, it showered the local area with lots of space rocks. And there was a fair few people, and I'm guessing that Ezzy is going to tell us how many people that actually went out there to try and find these meteorites. But Ezzy was one of them, and actually made a documentary for Channel 4 called Meteor Strike, Fireball from Space. And tonight, Ezzy is going to take us through that journey that she went on, all about the meteor and the trip out to see it. So, Ezzy, without further ado, I'll hand over to you.
Hello, everyone. Let me just share my screen with you so that you can see my slides. There we go. All right, so hello. Yes, as I was introduced, I'm Ezzy Pearson, and I'm a science writer and journalist about all things space. And back in 2013, I was doing my PhD over in Cardiff when a certain event happened over in Russia. It in fact happened in an area known as the Chelyabinsk Oblast. And on the morning of the 15th of February 2013, at about 9 a.m., everybody in the local region of the town of Chelyabinsk was just getting ready to go to work. It was a normal day for everybody as far as they were concerned, when suddenly they saw something appearing in the sky overhead. And this is what they saw. There was this sudden bright flash of light in the sky, something streaking across the sky, huge and bright. And so, yes, there was this bright flash of light, something streaking across the sky. They could see some sort of trail coming off behind it. And nobody was really sure what this thing was. I mean, you see this, for most people who aren't astronomers, you see something bright flashing in the sky. And it was really, really bright. It was actually brighter than the sun. You know, it was bright enough that it was creating the dominant shadows rather than the sun was. And so everybody did what you would normally do if you see something strange in the sky that you don't know how to explain. They went to have a look at it. They went to look out, unfortunately, next to the windows. And I say, unfortunately, next to the windows, because approximately 2 to 3 minutes later, this happened. So I don't think you can hear the audio for this, but there's a big bang just as you see there when all of the windows fell out. There's this colossal boom that sets car alarms off, blows out windows. And in this particular case, collapses a ceiling. And this is the one I always make sure to leave it until. Blowing people through walls. So this was a really, really strong shockwave that got sent through the town. And it caused an enormous amount of damage throughout the town of Chelyabinsk. So Chelyabinsk is predominantly a mining community. It's very industrial. On the top left, I know my left from my right. On the top left is, you can see that building. That's actually a zinc factory where they process zinc. And this shockwave blew out windows, collapsed buildings. It was a huge thing. And unfortunately, it blew out windows. As I said, a lot of people had gone to windows to look up at this amazing thing in the night sky. And the glass shattered and cut people. The sun was so bright, people actually got sunburn and retina burns. And in total, about 1,200 people ended up having to go to hospital because of this huge explosion. And at the time, nobody was really sure what it was that they could see. There was people saying, oh my goodness, it's the Americans, they're finally firing missiles at us. There was in fact a Russian politician who went on the record and saying that that's what this was, and that the Russians wouldn't stand for it. However, of course, that wasn't what it was. What it actually was a meteor. And the things that gave it away were the fact that there was a smell in the air, the fact that there was a sulfurous smell, it's reported, like there was burning or ashes. And then shortly after the explosion, there was something that sounded like rain falling on the roofs, or more accurately, more like hail, as hundreds and thousands of tiny, tiny little pieces of gravel, little meteorites, fell down onto the region of Chelyabinsk. Said that they fell like rain over the entire region. And it's estimated that this shockwave cost about 1 billion rubles in damage. That sounds pretty extreme. It's only about 20 million pounds, which is still a lot. And it caused a lot of damage to the area that had to get replaced. So as I said, what was this? Was it a missile? No, it was a meteor. And so some quick bit of terminology, just so that we're all 100% sure. When you've got a space rock in space, it's a meteoroid, sometimes also referred to as an asteroid or a space rock. As soon as it hits the atmosphere, that becomes a meteor. And that's the bright things that we see during meteor showers, or when you see, if you've been lucky enough to see a fireball in the sky. And any part that reaches the Earth, that touches down, that is a meteorite. So if you've got a rock that you picked up that fell from the sky, that is a meteorite. So what actually happened on that day, on the 15th of February? At first, people thought that something might have happened from an asteroid that we knew was coming by the solar system, the Earth even. There was an asteroid called 2012 DA14. As ever, asteroids always have incredibly succinct and emotive names, which was about the size of an office block. And that passed 27,500 kilometers from the Earth. So it was quite a close passing one. It had made a couple of headlines around the world. But then this happened and people thought, oh, it's a bit broken off. Turned out pretty quickly that people said, no, it was coming from completely the wrong direction. It was in fact coming out, this meteor probably came out of the direction of the sun, which is why people didn't see it beforehand. And this isn't the first time that people in the region of Siberia have experienced a massive shockwave from a meteor and a meteorite. Quite famously, there was the Tunguska meteor back in 1901. And this was probably the last time that Earth got hit by a really big meteor, or at least we think we got hit by a big meteor. It happened in a mostly barren area of Siberia. And the reason why we think it was a meteor is because all that we know about the Tunguska impact was that a huge area of a remote part of Russia got completely flattened. So these are all trees that you can see in this picture that have just been completely flattened by some form of shockwave. But what they never managed to find was any pieces of the impactor. So any pieces of the thing that actually caused this impact blast to happen. And the thing about this is it happened back in 1908. And another reason why we don't know much about actually what caused this impact is because it happened in 1908. Today, the Chelyabinsk impact, that happened when people had CCTV cameras and smartphones and dash cams, lots and lots of dash cams. Recording this event as it went across. So we had lots and lots of footage of it. And that is what makes the Chelyabinsk meteor so incredibly exciting to scientists and researchers. So this is the region where it happened in. And as I said, it could be seen throughout this entire region. And it was being tracked coming across from Chelyabinsk all the way over, I don't know if you can see my pointer, but over here towards Oskirk, on a region called Lake Chebarkal. And people seeing that this is where the light seemed to be going went out and investigated, and they found in this region, this remote lake called Lake Chebarkal, they found an 8-meter wide hole that hadn't been there the day before or the last time that somebody had been down there. And at first, they didn't know whether or not it was caused by the meteor falling into the lake, but the fact that there was an 8-meter wide hole there when there hadn't been one yesterday, people were pretty sure that's where it'd come from. And so people started to really pay attention to this. And it was now getting to be the rest of the world was beginning to wake up. So this happened at 9:20 a.m. local time, which is about 3 a.m. GMT. So as time went on, the rest of the world started to wake up, hearing these incredible stories first on places like Twitter, and then eventually through other more legitimate methods, I suppose, that there had been this incredible thing that had happened in Russia. And one of the people that started looking to find out more information about this blast, about this impact, was the people running the Comprehensive Nuclear Test Ban Treaty Organization. So what is that? They are the people responsible for making sure no one is testing or detonating nuclear weapons in a way that they shouldn't be. And they have infrasound stations all over the world. Infrasound is very, very low frequency sound. It's the kind that tends to be created by seismic activity, and it travels incredibly long distances through the Earth. There are 45 infrasound stations across the world, and 17 of them picked up this Chelyabinsk event, including one in a station in Antarctica over 15,000 kilometers away. So this big boom that happened in the sky was pretty big. And it measured that the detonation happened at 3:22 GMT. And what it also noticed is that there was more than one detonation. There was, I think in end, there was 7 detonations as this thing broke apart, because that's what happened. That's what caused the shockwave. When that meteor came in through the atmosphere, it caused an incredible amount of air to heat up around that meteor. Whenever you see a meteor and it's glowing white hot, it's not the meteor that's glowing, it's the air around it as it's getting compressed at enormous speed. And that creates a lot of heat as well as a lot of light. And when you subject a rock to a lot of heat, sometimes it shatters. And that's what happened here. At 3:22 GMT, the Chelyabinsk meteorite got so hot that it just broke apart. And it didn't just break apart once, it broke apart 7 times. And each time that created a huge shockwave as the pieces sped apart from each other. And that was the shockwave that knocked everybody on their feet back down on the ground. And this is probably the biggest meteor blast that we've seen in a inhabited area since we've had, you know, ways of measuring this sort of thing. Anyway, back to the nuclear test ban treaty people. They discovered that it had exploded 7 times. They also worked out how much energy it had dumped into the atmosphere when it had done that. That blast had had the power of 500 kilotons of TNT. To put that into perspective, the bomb that they dropped on Hiroshima was about 15 kilotons. So this is 32 times more powerful than a nuclear bomb. Fortunately, it happened quite high in the atmosphere. So rather than completely obliterating the town, it just had this huge shockwave. Also, from the amount of energy that it managed to dump into the atmosphere, scientists began to hypothesize about the rough size that this thing might have been. And people said it probably was no bigger than 50 meters across. In asteroid terms, that's a fairly small asteroid, and it still managed to put 30 nuclear bombs into the atmosphere. Of explosive force, not actual nuclear bombs. That is an important distinction to make. Yes. And people, as well as this happening, something very exciting had happened. So people began to upload their footage of the event onto Twitter, onto Facebook, onto the internet. And various people around the world began to look at this footage and try to work out whether or not they could extract any scientific data about the blast and about the meteor from it. And the first thing they did was try to work out where the meteor was coming from, which is what this GIF is about. Now, as I said at the beginning, the meteor was incredibly bright. It was so bright that it became the dominant light in the sky. It was what cast the shadows, not the sun. So people used footage like this, which is of the main square in Chelyabinsk, and tracked this path of the shadows. They looked up on Google Earth, Google Maps. So they looked up on Google Maps how far apart the light posts were, how high they thought they might be, and managed to use this to begin to triangulate exactly where, how fast, what direction they thought this meteor was coming from. And people all around the world were doing this. There was loads of people who were doing it, and eventually they began to make a framework of exactly where they think this meteor was coming from. So all of those different orange triangles are kind of the zones that people said from this one particular image, from this one particular piece of footage, we think the meteor might have passed through, and began to build this path through the atmosphere of where they thought the meteor had come from, with its final landing point of Lake Chelyabinsk, where they found the big hole. And the more information they got, the more videos that came in, the more people were starting to look at it. They began to work out that they think that there was an airburst at 30 kilometers, I think the final sort of rigorous thing put it at 27 kilometers that this thing first broke apart. And it was traveling at 19 kilometers per second. That is incredibly fast. And it was also coming in at an angle of about 18 degrees. And what they think actually happened is that on that first split, the meteor broke into two clouds almost of much smaller debris and rubble, and those carried on their way and scattered over the surrounding region. And now that they had plotted the path of where they think the asteroid was coming from, why was that important? Why did people do that? Well, if you know where it's come from, then you know where if you know where it was going, then you know where it came from. And you can backtrack its path right the way from Earth back to its orbit around the sun and its orbit around comparative to Earth. And that's what people began to do. This was a much longer process. This took several, weeks to start coming through. And asteroids tend to hang out in a couple of there's asteroids everywhere throughout our solar systems, but they tend to hang out within very specific points. There's the asteroid belt, which is that region you can see in white. Then there are something called the Trojans. These are basically, every planet has a place where there's a gravitationally stable point, and asteroids tend to kind of get stuck in there and sit there. Jupiter is the only planet that really has a lot of asteroids stuck in there, but Mars has a couple, Saturn has a couple. Earth, people debate it. I think they're looking for the Trojans of Earth, but nobody's actually managed to find them yet. And then there are also some which are coming into the inner solar system. You get something called near-Earth asteroids. And what near-Earth asteroids means is anything that crosses or is within the orbit of Earth. And most of those asteroids, the ones that come close to Earth and the ones that we tend to concern ourselves with most, are ones that started life in the asteroid belt. We think most asteroids started life in the asteroid belt, but at some point in the past, they got kicked in towards the solar system, maybe through some interaction with Jupiter, or two asteroids colliding together and shooting one off towards the inner solar system. And that's where people think the Chelyabinsk meteor originated from. It's one of those ones that got shot in towards the inner solar system. And so people began to plot the Chelyabinsk meteor. And this was the initial path that they came up with. So it's the one you can see in blue here, with Earth's orbit in green and Mars' orbit in red. So it came past Earth's orbit quite regularly. It sort of crossed over Earth's orbit. It just happens to be that this time Earth was there when the asteroid got there. And in fact, they tracked back this path so much that they worked out, they think, that the Chelyabinsk meteor was originally once part of an asteroid, a specific asteroid, called 1999 NC43. Again, really good at naming asteroids, which was in the asteroid belt. It's a 22-kilometer wide asteroid. And what we think happened is that about 1.2 million years ago, maybe more, maybe less, something happened that chipped off a fragment of that big asteroid and sent it hurtling in towards the solar system. It crossed over Earth's orbit, and that's what became the Chelyabinsk meteor. And this is the path that we think it took. So this is just showing you the orbit. There's no time moving on at the moment. So this is where we think Earth, Mars, the Sun, and the Chelyabinsk meteor were 4 years ago. And then in a minute, the timer will start and you'll see how this meteor moved around in a minute. So as we can see, the meteoroid crosses Earth's orbit 2 years before it hit. But this time, Earth was in the same place. So it's crossed Earth's orbit possibly many, many times. It just happened to be that on the 15th of February, 2015, when it crossed over, Earth was in the same place at the same time. And we had a big kabloomy. Technical term there. Now, that was people throughout the world looking at footage that was being put up. There were, however, a lot of people in the region. It was remote, but it was inhabited. There are a lot of people in the region. And they saw these meteorites falling from the sky like rain. And the people of the region immediately knew that this was going to be of great interest, partly to scientists and partly to meteorite hunters, people who wanted a fragment to take home with them and put on their wall. And so a lot of people in the region started going out. Some of these people were from the Ural Federal University, because it just so happens that about 2 or 3 hours down the road from Chelyabinsk, you have the Ural Federal University, which has an entire department dedicated to researching meteors and meteorites. And that's because of the Tunguska meteor ended up in that region, the Tunguska event. So this university started taking that out. And the people from the Ural University, they went out, they started trying to collect these meteorites from the snow, from the ground. And they kept track of exactly where they found these meteorites, which a lot of the people who were going out there didn't. And that you can see here on this map in red, every one of the red dots is where they found some meteorites as they fell from the sky like rain. There's a sort of red oval, which is where there was just so many that they couldn't even put individual dots down. It was just this huge entire region. And you might be able to see that there's a sort of yellow series of ellipses running down. That is showing you where in its path each one of the explosions, each one of the individual breaking apart of the meteorite happened. And as you can see, every time it broke apart, directly underneath, there's a whole bunch of meteors as they just dropped out of the sky. And the reason for that is because it's basically when you have something small, the air resistance was much more able to stop it and it just falls straight down again. And of course, it wasn't just people in the local region that started getting wanting to go out and hunt and find these meteorites. People all around the world suddenly started to want to get there, to track across the land and find these meteorites. And so people started flying in from all around the world to try and find these meteorites. And it just so happens that actually the middle of Siberia in winter, when there's snow on the ground, is one of the best climates and best places to try and find a meteorite, because everything is covered in pristine snow. Fields and fields and fields of absolutely pristine snow. So if you see a little hole in the snow, that means either you've got a mouse or something has fallen from the sky onto the snow and created that hole. So if you dig down into that hole and you find a little rock, chances are that's a meteorite. So, and here is what it looks like when you find one. Now you'll notice that on the right, a lot of the meteorites there's like a kind of like a bit of black stone on top of a kind of column of ice. And what's happened there is when these rocks fall from the sky, they're very, very hot. And so they melt the snow, they melt the ice. That's what creates that tunnel, rather than kind of, it's partly, something dropping and its speed, but also its heat melting the ice. And then the snow refreezes around it because it's really cold in Siberia. It's very cold in Siberia, and creates these sort of columns of snow and ice. So if you're ever wanting to find a meteor in the middle of a snowfield, what you need to do is you need to look for holes in the top of the snow, dig around it, sort of kind of scoop around the edges around the hole, getting closer and closer and closer. And you want to go down a good foot, maybe 2 if you can. And then when you've just got in like a couple of centimeters around the hole, a couple of inches around the hole, you scoop through and try and find these columns, try and find that black lump of meteorite. So if you ever get the chance, that's how you do it. And there was a lot of the people who went out and did this were the locals. Apparently, because it's not a very affluent area, so a lot of the kids, as soon as school was finished, they ran out there because this was their chance to, they bung these things on eBay, and they'd earn themselves enough money to get like a PlayStation or an iPod or something. But there was also a lot of researchers, as I said, from the Ural University. And it was all these people rushing out there. That was when I got a phone call. So on the actual day of the event, I got a phone call from the BBC saying, do I mind coming on and talking about it on the radio? This is something I quite often do just because I have a good background knowledge in pretty much everything to do with space. So I can give some quite good knowledge about most things. And a couple of weeks after that, I got a phone call from Channel 4 saying, hey, do you fancy going out to Russia to do a documentary on this? And I said, yes, because you would. And so after 2 weeks of frantically running around trying to sort out passports and visas and making sure I had enough cold weather gear so I didn't freeze, I went out there, started hunting for these meteorites. That's how I know how you find them. And we eventually went to see what the researchers at the Federal University were doing with them. So here we see, this is some of the meteorites that were being discovered across the region. In that, this was probably about 3 weeks after the initial blast happened. And here we have, on the right, you can see the hands of the lecturer at the Ural Federal University called Viktor Gorkovsky. He was like the head honcho, the man who was in charge. And they were quite jealously guarding their meteorites. They didn't like the fact that everybody was going out and grabbing all of them up. And so very early days, they were, cutting these up, putting them under the electron microscope, trying to find out what was happening. And in his hand, you can see that there is a huge lump of meteorite. That weighed about 1 kilo. Was deceptively heavy. It felt a lot heavier than it looked like it should do. We'll come on to why in a minute. But that was the largest single fragment of meteor that got found by the Ural University during their searches. It's estimated that the meteorite originally the meteor was probably 10 to 20,000 tons, but only about 2 or 3 tons of material would have made it to the ground as meteorites. Sorry, there's fireworks in the background, and I'm talking about meteor explosions and there's fireworks. It's very confusing. And so yes, so there was 3 to 4 tons of meteorites on the ground, and the rest of the meteor probably vaporized in the atmosphere. But this was the biggest fragment they found until the summer, because, as you all remember, there was a massive hole in the middle of Lake Chelyabinsk, and so the in the months leading up to summer, you can't exactly go. Well, you can go diving for a massive meteor in the middle of a lake in the middle of Siberia in the middle of winter, but that is what is known as a bad idea. And so they didn't do it straight away. They waited. But during the winter, whilst this lake was still frozen over, they sent out a group of geophysicists, as you can see here on the top left. And that is them as they are surveying the entirety of the lake. And what they're doing is they're trying to work out the topology of the underground of the lake to see what's going on. I don't know if any of you were ever Time Teen fans back in the day, but it's basically, that's what, when they did the geophys surveys, it's the same thing. And they were looking for any craters in the floor of the lake, and they found one not that far away from where the big hole was. And in fact, what they found was it looked like the meteorite had bounced and created 2 big dips in the bottom of the lake. And so they knew in the summer where they should go looking for it. And as I said, until the summer, until the lake had properly thawed. And they sent a couple of divers down first to try and locate what they thought was this big fragment of a meteor. This huge meteorite. And they eventually managed to get it out of the lake, and it was a huge production. They had to have divers, they had to dig the mud away from it. It took 10 days to finally haul this thing out of the lake. It broke the crane that they were using to drag it out. It broke the lift, broke the scales that they were using to weigh it. And they eventually measured it was about 570 kilograms, which is pretty heavy. It's about the same weight as an original Mini. And eventually managed to drag it out of the lake. And when they were dragging it out, they'd tied it up and put it in this big tarp that you can see in blue there to protect it and make sure that nothing happened to it. And as they were unwrapping it, they'd spent all of this effort to try and get it out of the lake in one piece. The second that they got it out, it completely fell apart. It broke into 3 huge pieces almost immediately the second that they unwrapped it, which was a bit distressing for them. Unfortunately, that's how meteorites work. Sometimes they just crumble on you. Now, there were some debates as to whether or not this was actually a meteorite or whether it was just some rock that had found in the middle of a lake. The Russian media is not brilliantly well known for admitting that they've made a mistake. However, tests that have been done on it subsequently have shown that yes, this does at least appear to be a meteorite, and the same kind as they found in the rest of Chelyabinsk. So what kind of meteorite was it? Well, it's what's known as a chondrite LL5. A chondrite means that it's not been modified by melting. So it was never part of a planet. It's the original stuff that the planets are made out of. It's the original pieces of rock that condensed when the solar system was forming. It's stony, meaning iron, low metal. Not a lot of metals in it. It's just stone. That said, the 5 is because it's a bit more metallic than other things that are not metallic. And these kinds of chondrites are the most common of meteorites. They make up about 85% of meteorites and most of the asteroids in the asteroid belt. And what they found when they started looking at these rocks was that they contained a lot of something called shock fractures. And what is a shock fracture? Well, what this is when you get two meteorites, two asteroids in space, and they whack against each other, that sends shockwaves right the way through the stone, through the rock, and that can cause some fractures to form. And you can see them in the form of these dark lines running through the asteroid. And now is the point where I'm going to attempt to show you on my camera my fragment of the asteroid, and we'll see if it works. Okay, so I've got a light going on. Right. I don't know if you can see this very well. I don't think it's going to work terribly well, but so you might be able to see that there is a big black line running through the middle of that. Might be better without the light. Yes, actually it is. So there's a nice big black line running through it. That is a shock fracture going right through the middle of that. And that was created millions and millions of years ago when the Chelyabinsk meteorite got chipped off of that original asteroid. It's also got a nice black crust on it. As you can see, like there, it looks almost completely black. And that is what's known as the fusion crust. That comes when the meteorite is falling through the atmosphere. It heats up, it melts the outer layer of rock. So that's not something that if you found this in space, it wouldn't look black on the outside. But those black veins are. And all of the meteorites that they found from the Chelyabinsk meteor were completely threaded through with these black shock veins. It was one of the reasons why we think it crumbled up so much was because it's filled with these huge black shock veins. Because they're weak points in the rock, basically. And as soon as it was put under any kind of stress, the thing just crumbled and fell apart. And here we can see some more details of the scientific process behind it. A is just a slice through of the meteorite. B is quite interesting. It's showing you where the iron is within this meteorite. And the iron is shown in green. And as you can see, it's forming in these distinct lines. So those are the lines of the shock veins. The kind of iron sinks into those as the fragment heats and forms these fractures, these veins. And then on the right is just a series of showing you how the kind of makeup of the asteroid fits in with other generic type of asteroids. And it seems to be just a fairly typical LL type of asteroid. It's nothing particularly special, which is actually brilliant if you're a researcher and you want to try and find something just fairly typical. They also ran it under their scanning electron microscope. That's me there with Sergey as they were doing so. And again, this just showed you the sort of what it looks like up nice and close, and it looks like an ordinary bog standard LL chondrite. And this again is showing where the iron was inside the meteorite, and it's kind of that's what you can see in green is the iron-based compounds, and so there's this iron threaded throughout the meteorite, but it doesn't make up its main body. And this is another sample. Basically, this is a sample of the asteroid as taken from the lake, Lake Chelyabinsk, and number one is a sort of baseline comparison LL chondrite, and number two is this one, showing that this definitely seems to have been a chondrite. It was the bit that they found in the lake was something that fell from the sky. And so, as I said, it's a fairly typical meteorite. And so once they'd managed to establish exactly what this meteorite was like, it is now just become part of sort of sciences and the sort of great database that people can call upon. So if people want a typical sample of LL chondrite, they might request a sample from the Ural University that they can then take away. So it's now just become part of our greater understanding of how meteorites and asteroids work. And there are many different kinds of meteorites. For instance, there is iron meteorites. Now, iron meteorites have once been part of something called a planetesimal, so a baby planet that never quite made it. And iron meteorites are much more solid. They only make up about 5% of meteorites, but because they're massive lumps of iron, they make up about 90% of the mass that we find. They were earliest sources of iron on the world, of people falling down from the sky, pretty much pure. And those ones are also of interest to people researching, because whilst chondrites tell people researching about asteroids, it tells us what was there at the beginning. They never got to be part of the planets, the chondrites. So they tell us what the raw building blocks of the planets were. However, the iron meteorites tell us what happens next. This is pretty much the only chance we're going to have to look to see at the iron core of a planet, is when you look at an iron meteorite, because that's essentially what it is. Also has a really cool thing called a Widman-Stanton pattern, which I just put in here because I like saying Widman-Stanton pattern. And this is basically when because of the unique ways that meteorites cool, they create this fantastic crystalline structure which you can polish up and get made into jewelry and things. But yeah, that's really pretty. There's also another kind of iron-rich meteorite called a palisite. And palisite originates from the core mantle boundary of a planetesimal. So these planets were just beginning to differentiate, just be able to grow into something we would recognize today as a planet, before they got completely blasted apart and obliterated, forming a bunch of asteroids. And that's what a palisite is from that very specific place in a planetesimal. It's also very pretty, very cool, and sometimes very big. But not all meteorites come from the origins of the space, origins of planets, or planets that never were. Some of them actually come from planets or planetary bodies themselves. Occasionally, we get meteorites on Earth that originated on Mars or the Moon. So many, many years ago, they had their own meteor impact, but one that actually impacted the surface with enough force to create a crater and throw up a bunch of space rocks. And sometimes those space rocks make their way back to Earth. There's possibly, we might have meteorites that come from other planetary bodies, but we only know about the Mars and the Moon because we know what Mars and the Moon look like, because we've sent robots there, we know what they look like. And another reason why people like to study meteorites is because they're the only way of getting our hands on asteroids. And asteroids can tell us about how the planets formed. You know, it's the raw components that the planets were made out of. It's the bits left over from the planets that didn't quite make it. And so a lot of people are now really interested in finding these samples. And today, most of the samples that we have of asteroids are actually meteorites, because until quite recently, we'd never been to actually see a meteorite, an asteroid directly. However, that changed since I last gave this talk, because now we have winging their way to us from asteroid Ryugu and asteroid Bennu, two samples that we've got taken by the OSIRIS-REx from NASA and JAXA's Hayabusa 2 mission. These were two missions to go up to asteroids, collect a sample, and then come bring it back to Earth. So very soon we will actually have like a direct sample from an asteroid. However, that was very expensive. it took a long time, and in Jax's case took 2 goes to get it right. It's much more reliable if you can just pick up a meteorite off the ground. Unfortunately, most cases, most meteorites, we don't know where they came from. We just pick them up off the ground in the desert or in Antarctica. We might know that they're a meteorite, but finding their provenance is quite difficult. And that's why the Chelyabinsk meteor is so important, because we could track where it came from, because it was seen by so many people. We know exactly where it came from. We can track it back to exactly which asteroid it first started from. And that's brings us to my big question of the end of why do we care, and are we all going to die? One of the reasons why people tend to be a bit scared of every time that we hear in the news that there is a meteorite coming close to Earth, people tend to get a bit concerned that you know, something passing by and it might accidentally hit Earth, or it might accidentally come hit us. And the answer is that at some point, we are going to have another big meteor strike. That is something that will eventually happen. Whether or not it will happen in Earth, in humanity's kind of frame of awareness, that's another big question. So as I said at the beginning of this talk, we think that the Chelyabinsk meteorite was probably somewhere about less than 50 meters wide. That is relatively small. So we say that a meteor that is going to when people are tracking meteors, anything above 140 meters is what's classed as potentially hazardous. That's the size it takes to wipe out a city. Anything that is bigger than a kilometer across, that's what you call a civilization killer. That's the ones where you really have to worry. And fortunately, we think we know where most of those are. There's a lot of people out there who are possibly, in some people's opinions, not enough, but there are quite a few initiatives out there that are tracking every single meteor that we can possibly see that crosses or comes within 5 million miles of Earth's orbit. This picture's probably a little bit outdated by now. We know even more by now. And this is the path of every single asteroid that they have tracked. However, they stop tracking at 140 meters. That's their kind of goal, is to try and be able to track 95% of all meteors that are over 140 meters across. That does mean, however, that some of the smaller meteorites, like the Chelyabinsk meteor, are going to slip through the cracks. But fortunately, you don't have to worry too much, because most meteors, like the Chelyabinsk meteor, we do get struck by them actually relatively frequently. Ones about the same size or slightly smaller. However, most of them happen in incredibly remote areas, or they happen high up in the atmosphere. They break apart high up in the atmosphere so that we never really feel them or experience them. So whilst meteors falling and raining down from the sky is definitely something that we should keep an eye on or be concerned about, I don't think that we have any problems with them suddenly coming out of the sky and killing us all. So hopefully that's a really nice note to end on in the middle of 2020, but we are probably safe from meteorites falling on our heads from the sky. So thank you very much. That's been me. I had most of my scientific things were taken from this paper. So if you want to know it, that's what it's called. And also, if you're interested in more space missions, as was mentioned, I have a book out. So please, if you have any questions about meteorites or anything like that, please do ask.
Super. Thank you very, very much. That was fascinating.
It certainly was. Yeah, apologies, Grant. My screen has just completely died for some reason. I can hear, but I can't see, and so forgive me just for a second. Yes, indeed, very interesting. Grant and I had sort of both made the comment in the chat. I don't think we quite realised how actually destructive that that burst was over the town.
Yeah, it was because, as I said, I went about 3 weeks after the event, so things were beginning to get. Basically, it was gotten to the stage where they would either replaced all the things that they were going to replace, or ignore, like, let the things they were going to fall down. And it was, yeah, it was everywhere throughout the city that there was like replaced windows and just sides of buildings just gone. Yeah, it was a big thing.
I remember, and I suppose I guess lots of people have seen them on the on YouTube, on the internet as well. But I guess they don't give quite the sense of exactly what was going on, seeing them on a little screen like that.
Yeah, it's in some ways it's like I wish I'd been there, but also I'm very much glad I wasn't.
Certainly for the sonic boom afterwards, I think that would have been something, wouldn't it?
Yeah,
that would have been something.
The thing that shocked me was how bright it was, because it's like I'd seen the pictures and it's like, oh yeah, that's pretty bright, but it's like no, it was bright enough to like burn people's eyeballs. Wow. Because they happened to be glancing up at it and it suddenly burst out and was several times brighter than the sun.
So was there was no deaths caused by it? It was just injuries, is that? There
was fortunately no deaths, no.
Yeah.
Most of the injuries were from retina and skin burns and fragments of flying glass.
Pretty amazing.
There's also
really. You would have thought there might have been some car crashes or things like that.
There might have been car crashes, but it's Russia. They don't really. It's like literally on the way to the airport when we were filming the documentary, we got in a car crash. I think I saw another 2 happen whilst I was there. So
the state pays for all them anyway, so it's fine. It's not a problem. Okay, question. Lots of people saying it was an excellent talk, so thanks, Ezzy. Thanks very much for that. Question from Happy Cat. Hi, Kate. I hope you're well. Do meteors give off infrared, or rather generate the visibility of infrared as they enter the atmosphere?
As they enter the atmosphere, yes, they definitely would glow in the infrared because it's very hot, so they do give off infrared. However, because they're so bright, that tends to be most people look for their brightness, or use other sort of when you're tracking meteors. If it's the smaller ones, people tend to use things like radar bouncing off them physically. So infrared is a way that one of the ways that people track asteroids in space when they are looking at like when they're trying to track them, the sort of near Earth object surveys, because it might be in the space, it might be very cold, but it will still be hot. And so it's a lot easier sometimes to see asteroids in space in infrared than it is to see them in visible light. So that is one of the ways people look for them.
Excellent, thank you for that. And I had a question actually. Do people still go hunting out to Tunguska and Chelyabinsk?
Not anymore so much. Tunguska is one of those things. It's been so long ago. It's become a bit of a tourist destination sometimes.
Okay.
Well, as much as a remote place in literally the middle of nowhere, 100 miles from the nearest post of civilization, can be a tourist destination. But yeah, no, because as soon as everything thawed, any meteorites that were left just fell to the ground, and there's no way to tell whether it's actually a meteorite or whether it's from just a piece of gravel, which is one of the big problems.
Okay, bearing in mind it is a place in middle of nowhere, etc. There can't be much infrastructure for tourism. So when all these people from around the world suddenly descended, was there enough hotel rooms for all this demand? And
there was. As far as I believe, I don't think there was anybody sort of having to be put up from in a local's house or anything, because it was enough to be able to manage. There's not a lot of people out there who have the means or the impetus to suddenly drop everything and go hunting for meteorites. There was enough that it was, there was suddenly significantly more people in town than there usually was. but it wasn't, you know, sort of huge influx and huge hordes.
Good stuff. Question in from Drifter. Drifter, if you've got a microphone, feel free to unmute yourself. I'm going to go. Oh,
there we go. Yeah,
there we go.
It's first time on Zoom.
No, no worries, no worries.
Are we okay now? Can you
Yes, yes, yep. Ask away.
Oh yes, I just put in the chat. I put it. How confident are you can accurately back project where the meteor came from, which asteroid belt, which asteroid? I think you mentioned. As this debris goes round and round gravitational bodies in the solar system, is it easy to predict exactly where it came from?
It's partly it's not just about sort of saying it's like, oh, I've backtracked it and I know that like 1.2 billion years ago it was here in the asteroid belt and this other asteroid was here. That's not how it works. It's about sort of matching up trajectories. So they predicted the path and the actual path of the Chelyabinsk meteor in the last couple of years around Earth. That can be done incredibly accurately. The backtracking it to a particular asteroid in the asteroid belt, that's about sort of looking at the curve that the Chelyabinsk meteor took, and then doing various boring things with statistical analysis and trying to match up that trajectory with the trajectory of something in the asteroid belt that could have caused that, and that's how they match them together.
Could you see it incoming from past data of tracking bodies through the solar system? Like you said, you're monitoring lots of particles flying in.
Yeah, so the actual Chelyabinsk meteor itself had never been seen before. There is like people have gone back through various surveys, but the surveys have only sort of really started becoming massive things in the last decade or so. So back in 2013, they were all, many of them were quite new or didn't have the resolution to see something as small as the Chelyabinsk meteor. There's also the fact that it was flying, it appeared to come directly out of the sun. So its trajectory was such that it was flying too close to the sun, where the surveys just don't look, because the sun is there, and that makes it difficult to do astronomy, as I'm sure everybody is aware. And so they didn't see this particular one coming.
Look, can I ask one more question?
Please do. Yeah.
There was quite a few good dash cam videos of the object coming in.
Yeah.
And showing when it was beginning to fragment. I saw a very close-up section of one video which showed some other object coming in and very close by, and then the thing fragmenting. Have you seen that video? And do you think that there was some sort of thing coming in that might have been shot at it to make it fragment at that particular point, or is that a fake video?
I haven't seen that one, so I don't know. I'm inclined to think that it's probably either it's fake or it's something like it's a bird or something in the foreground that makes it look like it's flying in. But you can tell from the, like I said, those infrasound, the ones that were done by the Nuclear Test Ban Treaty people. That is a very, very specific profile of a meteor breaking apart in space, because it's broken apart, not because it's been shot at, not because it's things. It's how they knew immediately this wasn't a missile, it was a meteorite, is because there is a very specific profile that it follows, and that's what we saw on that day.
I mean, the fact that like an unidentified flying object might have fragmented it, that is, as in unidentified. Is that the close-up video of the fragmentation point? Have people looked at that closely to see if there's anything there that made it fragment? Or did it happen what makes it happen spontaneously? Fragmentation.
Basically, it fragmentates because it gets so hot, and eventually it reaches the point where the thing is under so much stress that it just gives. This thing suddenly it's been in the vacuum of space, and then suddenly is exposed to all of these really hot gases. It's an incredibly stressful thing for a rock to go through. Eventually it'll just reach that critical point where something will give and the thing broke apart.
And they've got those shock lines. We're going through it from the initial base impact.
So those are basically just weak points that made that happen more likely. If that hadn't have been there, there's every chance that it could have reached the ground in one much bigger piece rather than lots of small pieces.
Yeah, I was surprised the ice hole in the lake was so round and not, as it came in at an angle. I thought maybe the hole of hitting the lake, it would have caused an elliptical hole in the ice coming at an angle. Or do you think it just lost all its velocity and just dropped like a stone?
Yeah, well, with these, we're not 100% sure what happened, because people can model this until the cows come home, but it's quite difficult. With the smaller pieces, as soon as they broke off, basically, they didn't have the same amount of kinetic energy carrying them forward because they were so much smaller, even though they were traveling just as fast. So air resistance had a lot more ability to stop them, and they would just plop right down where they broke off, basically. Right. And so possibly that's what happened with the bigger fragment as well, because it was, most of the meteorite, it was originally much bigger. Most of its mass got vaporized as it was coming through the atmosphere, and so it's probably likely that the reason why it stopped is not because it met the ground, it's because it reached the air resistance, stopped it from being able to travel that fast.
You mentioned pallasites having lumps of, is it iron pyrites embedded in them?
So it's olivine. Is the gemstone.
So what is?
It has a bunch of other names, but yeah.
You showed that picture of the pallasites with this olivine. Is olivine in glowing like iron pyrites? It looked a bit like that. What's it embedded in? Because what surrounded it in your picture looked very, very clear, and I was wondering what substance it was embedded in.
So there's kind of, you get like a metal framework, which is the iron and nickel around the atmosphere, and embedded in that are olivine crystals. So the clear bits is the olivine, and around it is iron, as a sort of iron nickel mixture of metals.
Thanks very much. I'll let somebody else have a go.
Thanks, Drift. Good. No, not at all. Good set of questions. Well done on your first time on Zoom.
Ezzy, I just had one on the kind of impact that this has had afterwards, sort of politically. Has it increased funding in any of the searching sort of projects? Has it caused governments to pay a bit more attention?
It happened apparently the week before. There's something called, I think they're called the B612 Foundation. I think that's the right number. Who are a group in mostly America. They're international, but they're mostly American. That goes around and tries to campaign for more people being more aware and actually searching for asteroids. And apparently they had a meeting a week later scheduled in with Congress to ask for more funding to study for meteorites. It definitely, it let people, it made you have a definite case for, look, this is what happened. We had no idea this thing was coming, and it caused this amount of damage, and you can put a number on it and say, this was a small one. Big ones are going to be much worse. So it's been helpful in giving people an example. It's not just an abstract concept. It's a thing that has happened and will happen again.
And it cost money.
And it cost money. It's considerably cheaper.
Yeah. Just another question coming from Kate. I don't know if you see that, Daz.
I have now. I have now. Yeah. So would a higher iron percentage in meteors cause them to fragment more easily, or is it the reverse?
It's the reverse. So the more iron you have, the more solid it is. The reason why this is basically it got shocked and sort of had already fragmented apart before it hit the atmosphere. But when you get an iron meteorite, that's just like a solid lump of iron. It's like a cannonball hitting the Earth's atmosphere. So iron meteorites don't fall apart when they do hit the atmosphere. They tend to land in one big lump, whereas the stony ones break apart and fall much smaller meteorites.
Cool, thanks, Ezzy. And if anybody, just following up on my question earlier, anybody fancies a trip out to Meteor Crater, don't bother. John Huntley says that searching is not allowed around the Meteor Crater in Arizona, so that's another one not to go on holiday for then, righto.
Mm-hmm. Yeah, the most people where there is like a meteorite fall, especially if it's in a desert or somewhere snowy, they tend to be very careful and like because people do realize that this is, like it's a scientific resource, and they want it to go to the correct places. Mm-hmm. Also because if you're in somewhere like Arizona, especially if it's in the middle of somewhere that's got a lot of wildlife, you don't want people running around picking up every single rock and saying, oh look, I found a meteorite, when they haven't. They found a piece of gravel, because that's not good for your wildlife.
No, indeed. Nikki M, if you've got a microphone and you'd like to ask your question, you'd be very welcome.
I was going to say, should we finish on Nikki's question, just to give Ezzy her Sunday evening?
Well, that's very true. Yes, it's okay. Nikki's got no mic, so yes, we'll ask his question, although it's one specifically for Nikki actually. So I've got some fragments of one called the I'm going to get this wrong, Chelyabinsk meteor. What can you tell me about that one?
Chelyabinsk. I'm afraid I don't know specifically which one that is. Oh, is that the other Russian one from the 1947? Yes, the one from Russia 1947. I don't know huge about this, but again, it's another one that fell in Russia. Hang on, I had my notes on it and I skipped over it. There we go. So yes, it fell near the Sea of Japan, and it was a huge fireball that was seen across the sky and scattered rocks, and people went to pick it up, and people were picking up fragments of that one for several years, and that was eventually tracked back to the asteroid belt as well, because whilst it was again seen over a fairly populated area, but there weren't a lot of people around. They didn't have smartphones, you didn't have CCTV cameras, so it was a lot less reliable. But that was actually the first time that people had evidence that meteorites could be traced back to asteroids, because they had these samples, and they could just about use people's eyewitness accounts to track it back far enough to see that it came from the asteroid belt.
Yeah.
So that was the first time they made that association.
Excellent, great. Well, there you go, Nikki. There's some opportunities for more research, I think, for you on that one. And as Grant says, I think there's another questions coming in. Lots of thanks, Ezzy, for a great and interesting talk.
Thank you for having me.
Many thanks indeed.
Do you want to just mention your book again, Ezzy?
Yeah, please. I was about to say, if you put the picture up of your book.
I do. I meant to grab a copy and I forgot.
It looks like an excellent Christmas present.
It is. It's robots in space. Here, you see it here.
There we go. Superb.
All about all of the spacecraft that we've sent that have reached out and touched another planet.
Excellent. Where do we get that from? Is that
They posted a link up to Amazon, I think, for it. Yeah.
Yeah.
Excellent.
So
Thank
it's
you very
available
much.
through Amazon and all other good booksellers.
Thanks very much, Ezzy, for joining us. That's been
Thank you, Ezzy. Yeah,
Thank you.
many thanks indeed.
All
Grant, do we have a speaker for next week?
We do, yeah. Just before I say goodbye, we've got Peter Williamson is joining us again. He gave us a talk quite a while back now. This time he's giving us a talk on the myth to the moon and the story of the moon from ancient myths to the Apollo 11 landings, with stories from the family and astronauts he's interviewed over the years. So that sounds very, very interesting as well. And he's a
very good.
Great speaker. So we'll look forward to that one next Sunday.
Indeed. At which point then we will say thank you, everyone. Thanks so much for coming on. Enjoy the rest of your weekend, what's left of it. Have a great week, and we will see you all very soon indeed.
Night all.
Thank you all. Good night. Thanks, Ezzy.
Bye.